Hello everyone, my name is Sean Name, and today we'll be doing Fluent Project 1 for Fluid Mechanics, summer 2026. And we'll be doing part A, the Poisson flow. So first things first, you're gonna drag our fluid flow fluids, and you're gonna create a new standalone system. And so I'm just gonna create one right here, just refresh this. And then first thing I'm gonna do is go to Properties, change your analysis type from 3D to 2D. That is very important, as we're only doing 2D analysis today. And then right click again and click New Design Modular Geometry. And this is going to pop up a very SolidWorks looking interface. You can click XY plane and click on the Z, and you're going to get this beautiful little rectangle. Let's create a sketch here and just create a little rectangle, and we will go to dimensions. So we want to define our horizontal dimensions. So click this vertice, and you will get H1. And then vertical, you're gonna click the origin vertice, and up there, that will get you V2. And then to edit V1 and V2, let's first change our units to millimeters so everything stays correct. So this is 1500 millimeters for our height and 10 millimeters for our, 1500 millimeters for our length and 10 millimeters for our height satisfies that our length is 150 times our height. And once you have that, you want to go up to concept and then surfaces from sketches, and then go to box select this entire thing. It's all going to pop up yellow. Click apply, and that will apply that geometry, and then click generate, and that will create surface SK1. So once you have surface SK1, you're all done with this section of the project, and you'll get a nice fancy green little check mark right there. Awesome. So step 2, you're going to double click on mesh, and this might take maybe a few seconds to open. But once you double click on mesh, we are going to get a new system opening. Yep. So now we have our body, and our first thing we're going to do is choose edge. So this will let us easily select the edges, which you'll see why it's important in about a few seconds. So first thing we're going to do here is right click on this upper edge, insert a named section, and we're going to name this section, click this. So now it has a selection. Escape, sorry. Click here, click apply. So now that selection is made. Let's rename this to upper wall. And then we're gonna do the same thing down here. Let's right click, insert named section, click here, apply that to there, and let's rename this to lower, not like that, lower wall. Awesome. And then you're gonna click here, insert named section. In this selection, we're gonna rename it to inlet. I can spell inlet. And then same thing on this side. You are gonna click the very edge there, which will be tough. Then we go here and here. And right click, insert named selection. I'm gonna rename this to our outlet. So now we get started on meshing. So we're gonna click on mesh, insert sizing. And then once you click sizing, we're gonna control click to select multiple. We're gonna select the upper and lower wall, and then click apply to that geometry. So now it's selected the upper and lower wall. And instead of us by element size, we can do number of divisions and set that to 2500. Awesome. And then instead of capturing our curvature, there's no curvature capture. So we are going to set this to no, and our behavior will be hard. This makes our analysis much easier and correct for this project. So once that is done, you're going to click generate. So that first part is clicked, has meshed. Click here, and you can see that it's done a mesh, but we're not quite done yet. Let's go back on the mesh and insert another sizing. And we're going to control click our two outermost edges. We get the first one selected. And our second one selected. Click apply. Awesome. And then it's not quite done. Same thing here. Instead of we're going to number divisions for type and set that to not 540, please, 50. And let's do capture curvature set to no, and our behavior should be hard. So that all looks good, and we're gonna click generate again, and should get a 5% right here. And then you're gonna wait a minute or two for that to mesh, and then you will see the result after I come back. Water break back. We've done our two meshes, but now we are not quite done. You're gonna click on mesh, and we're gonna go to face meshing, select our body, our geometry, and click apply. Details of face meshing, and click generate. And it's going to do meshing again. And this one should be much faster. Should be ready now. We zoom in, we should get a bunch of fine little lines. Yep. And that looks all good. So now we are come out of this screen and open up our workbench. Right click and click update, and then it should buffer a little bit, and then we should get a nice green check mark. Awesome. And now we are going to double click on setup, and this might be a little laggy, but yeah, we want to make sure this says double precision, and we press start, and then another pop-up is going to pop up. Another pop-up is going to pop up here in a second. Just waiting. It should be much faster than the meshing though. Meshing can maybe take 2 minutes. So yep, still loading up. Just give it a second. You don't ever want to rush these programs as they can get a little crazy on you. Awesome. And now that we have this nice and open, and make sure everything's loaded in properly. The first thing that we were taught to do is go to results, click on residuals, and before that, we're going to change our flow. So let's click on, let's see, models, and click on this viscous SST-omega, and then something should be popping up here. Awesome. And then straight from omega, and we're going to change to laminar and click OK. And we're going to change these residual values to 1e to the negative 5. I'm sorry, 1e to the negative 6. Just copy, paste. This will make our results look a little prettier. So click OK. Sorry, just taking on my time here, making sure I do this right. It's missing a step here is critical. So then under here, we're going to go materials, fluid, air. Double click that. And we have this right here. And let's change our density to 1. 1e to the negative 5 for the viscosity. Change and create and close. Awesome. And then one way to check is to go to cell zone conditions and double click fluid. No, sorry, not fluid. Surface body, fluid. And then and make sure that it does have air selected, so press apply and close. Then we're going to go down to reference values. Let's like close some of these, make it a little easier on ourselves. Reference values, and we're going to compute from the inlet, and everything did update properly. Their reference zone is going to be the surface body. So that all looks awesome. And as for more initialization, and then so our boundary conditions, what we're going to change here for our was on flow. So for this project, we want an inlet velocity and 2 stationary plates. Let's double click on inlet. This is where we're going to set our velocities to, for my project 0.04 meters per second, which will compute us with the Reynolds number well under 2,500, meaning we have laminar flow, which is what we want. We'll click apply and close. And here in outlet, press prevent reverse flow, close. And upper and lower walls should be stationary with no slip conditions, apply and close. And the upper wall should be stationary with no slip, apply and close. It's already saved, but just double checking to make sure. Awesome. Close and close. And make sure our reference values are still correct. And then let's go down to a initialization and then click initialize. So then you should see in the bottom there doing a couple of residuals in the console. The hybrid initialization is done. We could go on to run calculation and then let's do 150 iterations and then calculate. We should get a message that our calculation is complete. So let's wait for that. See as our calculations are going, it's creating some scaled residuals. Okay, now we get this beautiful message that says calculation complete. Click OK. Awesome. And then let's go back to Workbench and let's double click on results. And now it's going to take another second to open. Just waiting for this to open. It'll take only a few seconds. This took about a good 5 minutes to open, but let's click on the Z-axis and let's add some lines in here because that took location and line. And we're going to call this first one the mid line. So there, midsection line, click OK. And this will be located at 0.7500, 0.75, and Y here will be 0.01, and 100 and samples. Just click apply, and yep. And this, I'm sorry, not 110 samples, will be 100 samples, and click apply. Awesome, and we'll click location, line, and this will be our end line. Click OK. And then for the end line, it will be not directly at the end, so it'll be 1.49. Oh, that is not right. 1.49, 1.49, and our height is 0.01, and the 100 samples apply, and you'll see it right at the end there. And then this is optional, but the video did it, and it actually is a good visualization. And we'll put our developing flow line, the developing flow. Okay, for developing flow, we will do some point below before the midline. So 0.1500 and 0.15, 0.01. Apply. That should be somewhere at the beginning here. That looks awesome. Now we have all our lines created on our sketch. So once those are generated, we press contour, name contour 1, and symmetry 1, velocity U, all domains, symmetry 1, and we'll do 110 contours. And click apply. So that is applying our contours now. And okay, it's the XY line, and our title is going to be velocity profile. Velocity profile for make sure I spell this right. Hello, awesome. Data series. So for our data series, we're going to change this to our midline. We'll call this midline. Let's apply. And new series 2 is going to be our end line. Awesome. And then a new developing flow. And then X is going to be velocity U, and Y. And Y is going to change to Y. Awesome. And you're going to click apply. And as created, the results for part A, I simulated the Poisson flow in ANSYS. The flow is modeled as two-dimensional and steady, laminar, and incompressible. So looking at these charts and everything, here the velocity contour shows the expected Poisson flow behavior. The velocity is 0 at the top and bottom walls because of that no slip condition. The highest velocity occurs along the center of the channel, as we can see here. We have velocity 0 at the top and bottom walls, and it's the highest in the center of the channel. As for the chart, the velocity profiles at the midline and end, it shows the velocity profiles at midline and end line. Both profiles have a parabolic shape, which is expected. And for pressure-driven laminar flow, that is what Poisson states that the flow is generated strictly by pressure. The maximum velocity occurs about y equals 0.05 meters and corresponds to 0.06 meters per second. The Reynolds number for my simulation is approximately 796, which is less than 2,500. So the flow is laminar and did expect the pulsar flow pattern. So again, we could just look at these one more time. See in the center of the channel here, we have the highest velocity. At the both walls, we have almost at absolutely zero velocity as we expected. So thank you for watching this video. Hopefully this helped. And to you that's watching, or Dr. Ozbay, thank you for this project. It did help me learn a lot. So thank you. And it's 10:15 p.m. So I'm gonna go to sleep very soon. And good night, or good morning, afternoon, night, evening, to whatever time you're watching this.